Every time you eat things that come from soil. But here's the problem. Now we're losing it. Globally, large areas of agricultural land are becoming less productive due to soil degradation. Topsoil is being eroded faster than it can regenerate. Nutrients are being depleted. Organic matter is declining. And the uncomfortable truth is modern agriculture is often extracting more from soil than it is putting back. If this continues, the system that feeds us begins to weaken. Not in theory, in reality. Soil is not just a physical surface. It is a living biological system. A single handful of healthy soil contains billions of microorganisms. Bacteria, fungi, and other microbes form complex networks that drive the essential processes. They break down organic matter. They recycle nutrients like nitrogen and phosphorus. They also improve soil structure, allowing it to retain water and support plant roots. One of the most important components is soil organic matter. This acts as both a nutrient reservoir and a structural foundation. When organic matter declines, nutrient availability drops, water retention decreases, soil becomes more prone to erosion. And then at the same time, intensive practices such as excessive tillage disrupt microbial communities and accelerate the loss of organic carbon. So the system begins to degrade from within. This is not theoretical. A recent example comes from East Africa, particularly Ethiopia and Kenya, during the 2020 to 2023 drought. This drought exposed a deeper problem. Soil degradation has weakened the system. Years of overgrazing, continuous monocropping, deforestation, and poor soil management had led to reduced soil organic matter and structure. So when rainfall failed, the soil could not retain water. And the crops did not just underperform, they failed completely. In many regions, maize yields collapsed, pasture could not regenerate, and livestock died due to a lack of forage. According to the Food and Agriculture Organization, over 20 million people in the region faced acute food insecurity during this period. But here is a critical insight. The drought was not the full explanation. Healthy soil can buffer dry periods by retaining moisture and sustaining crops longer. But degraded soil has no resilience. It loses water rapidly. It cannot support plant growth under stress. So the system fails early. And when it fails, the impact is immediate. Food production drops, livelihoods collapse, and the dependence on aid increases. This is what soil degradation looks like today. Not distant, not historical, but a present-day system failure under real environmental stress. The solution is not to abandon agriculture. It is to redesign how we manage soil. One of the most important approaches is often referred to as regenerative agriculture. The goal here is simple: restore the biological function of soil rather than degrade it. To do this, the key practices include reducing or eliminating excessive tillage, maintaining soil cover using cover crops, increasing plant diversity through crop rotation, and returning organic material back into the soil. These practices rebuild the soil's organic matter. They support microbial life, and they improve water retention. Also, they make the system more resilient over time. This is not about reducing productivity. It is about sustaining it. This is already happening at scale. A long-term field experiment by the Rodale Institute has compared conventional and regenerative organic systems side by side for over 30 years. The results are structural. Yields in regenerative systems match conventional systems over the long term. In drought conditions, regenerative systems produced up to 31% higher yields. Soil carbon has increased in regenerative systems, while conventional systems have shown carbon loss over time. The water infiltration is 15 to 20% higher in regenerative systems, reducing runoff and soil erosion. Regenerative systems also use 45% less energy and produce 40% fewer greenhouse gas emissions. Profitability in the regenerative systems has been 3 times higher due to lower input costs. And this is the key point. Regenerative systems do not trade productivity for sustainability. They outperform under stress. Now look at this at farm level. Gabe Brown transitioned from conventional farming after repeated crop failures. The shift was simple in principle. Stop disturbing the soil, keep the soil covered, and increase its biological diversity. The results were measurable. Soil organic matter increased from 1.9% to 6.1%. Water infiltration increased from 0.5 inches per hour to 8 inches per hour. Soil carbon content reached 96 tons per acre compared to 10 to 30 tons per acre in conventional systems. Crop yields increased 20 to 25% above the county average. Synthetic fertilizers, pesticides, and fungicides were effectively eliminated. This is not optimization. This is system transformation. The mechanism is consistent across both cases. Once you increase the soil organic matter, you increase the water retention, you increase the microbial activity, you increase the resilience, and you reduce dependence on external inputs. This is what sustainability looks like when it functions as a system. Soil sits at the foundation of the environmental pillar of sustainability. If soil is healthy, agriculture becomes more resilient, water use becomes more efficient, and ecosystems become more stable. If soil is degraded, every part of the system begins to weaken. The future of agriculture is not just about producing more. It is about maintaining the systems that make production possible in the first place. And that system starts beneath our feet.